Hello friends, welcome to the video lecture series of Engineering Mathematics 1. In this video lecture, we are going to discuss some multiple choice questions on Fourier series. Yes, in Fourier series, the applications of Fourier series, why the Fourier series is needed, already explained in previous videos. Now, examination point of view, the MCQs we are going to discuss. In this video lecture, only full range Fourier series we are going to discuss. In full range Fourier series, range 0 to 2 pi, range minus pi to pi, range 0 to 2l and range minus l to l is coming. Now, prior to the Fourier series, some preliminaries we are going to discuss very quickly. What is a periodic function? A periodic function is defined in this way. Function of x plus t equal to f of x. See, if you add this p in the function remains unaltered and t is the period of function and this must be valid for each and every x. For example, sine of x equal to sine of 2 pi plus x and 2 pi is the period of the function. Here again cos x equal to cos 2 pi plus x, then this 2 pi is the period of cosine function. Okay, there is one more concept of fundamental period. So what is my fundamental period? If function of x plus n t is equal to fx. If x is replaced by x plus n t and the function remains same, then t is called the fundamental period of the function fx, where n is a positive integer. Example, if sine of x plus 2n pi, then 2 pi is the fundamental period of sine x, because this is valid for n equal to 1, n equal to 2, n equal to 3, n equal to 4 and so on. If fx is periodic function with the period t, then f of ax is a periodic function with a fundamental period t by a. Once again, fx is a periodic function, then f of ax is also periodic function. F of x is periodic function, but f of ax will be periodic function with the fundamental period t by a. The example of fundamental period, the fundamental period of sine 2x is pi. See, sine of 2x in short is equal to sine of 2x plus 2n pi. Therefore, pi is what? Fundamental period of this. Here, fundamental period of cos 2x is pi. Okay, 2x is equal to 2 pi. Therefore, x equal to pi. Here, period of cos function is also 2 pi. Therefore, the fundamental period of this is what? Pi. The fundamental period of tan 3x is pi by 3. Okay, this 3x is equal to pi and x equal to what? Pi by 3. Fourier series of this function for 0 to 2 pi. This is full range. This is the formula for Fourier series, and where a0, an, bn are the Fourier coefficients. The a0 formula for an, formula for bn. Okay, this formula you have to remember. This Fourier series for 0 to 2 pi. Now, very quickly, some problems on Fourier series. Find the value of a0, an, bn for this function where x lies between this. X belongs to 0 to 2 pi. So in Fourier series, first of all, we have to check the range. What is the range? 0 to 2 pi is the range. Write a formula for a0. Put value of fx. Integration of x is x square by 2. Put x equal to 2 pi, upper limit and lower limit. 2 pi whole square means 4 pi square by 2, and put x equal to 0. Minus 0 means upper limit minus lower limit I did put, and 4 pi square by 2 is 2 pi square. 2 pi square by pi is 2 pi. Okay, this is the value of a0. Value of an is 1 by pi. This is the formula. 0 to 2 pi. Fx is what? X cos of nx dx. Here, this integral we are going to evaluate. The pi part I am going to use. This is the first function, this is the second function, and the generalized by part, integration by part I am going to use. If one in the product, if one of the function is algebraic function of the type x to the power n and n is a positive integer, in that case generalized integration by part is more convenient. Now, first function. Integration of cos is sin nx by n. Once you get the first term, From this term, the successive term can be obtained. Derivative of x is 1. Integration of this whole bracket. Here I am writing integration of cos, sine is minus cos nx by n is already there in the denominator. And in next step, derivative of 1 I have to write 0. Therefore, this series is going to terminate here. When you apply generalized by part, if power of x is 1, then you must get two terms, two non-zero terms, because rest of the terms become 0 because of the derivative. Derivative of x is 1, derivative of 1 is 0, like that. So 1 by pi, what I am going to do, the sine of nx for 0 to 2 pi is 0. See, here I am writing sine of nx for 0 to 2 pi is for upper limit sine n 2 pi minus for lower limit sine 0, put upper limit and lower limit, sine 2n pi is 0 and sine 0 is 0. Therefore, sine nx for 0 to 2 pi is 0. Therefore, you can cross apply. Sine nx for 0 to 2 pi is 0. Now, this term has gone minus plus cos of nx, this divided by n square, 0 to 2 pi. Now, 1 by n square pi, put x equal to 2 pi, upper limit cos 2n pi, minus put x equal to 0, cos 0, 1 by pi n square. See, cos 2n pi is 1, because if you go on putting value of n equal to 1, 2, 3, 4, 5, 6, all values of cos becomes 1. Cos 2n pi is 1, cos 0 is 1, 1 minus 1 is 0. The value of a0 is what? An is what? 0. So very quickly, we are going to find out value of bn. 1 by pi, the formula is what? 0 to 2 pi. fx is what? X. Sin nx dx. Apply generalized by part. 1 by pi is equal to sine. First function, integral of sine minus derivative of x is 1, here I am writing, and integral of sine is minus cos nx by n, and cos of this is what? Sin nx by, this is sin nx by n square. Integral of cos is plus sine, and it is 0 to 2 pi, and cos sin nx for 0 to 2 pi is 0. Therefore, this will get removed. Bn is equal to, this only term is remaining. This minus I am taking outside, n also I am taking outside. X cos nx is remaining for 0 to 2 pi. Now, minus pi into n, put x equal to 2 pi. Cos 2n pi is 1, directly writing. Put x equal to 0. 0 into this will be 0. Pi gets cancelled. Then 2 by n. 2 by n is the value of bn. And putting all those values means value of a0, value of an, value of bn in this formula of the Fourier series. So finally you will get the Fourier series. See, what is the Fourier series? This implies, one implies fx is x, a0 by 2, a0 is what? 2 pi, summation, n varies from 1 to infinity, an, what is the value of an? An is 0, plus summation, bn is 2 by, bn is what? This minus sign, pi, it is minus 2 by n, this minus sign I forgot to write, minus 2 by n, pi gets cancelled, then minus 2 by n into sin nx. This is a Fourier series of x for the range 0 to 2 pi. In online examination, it is less likely that the value of an and bn will be asked in the examination. The value of a0 is important. In the next problem, the value of a0 in the Fourier series of the function, the range is given. Now what to do? 1 by pi, 0 to 2 pi, this is a formula for a0. fx is what? E raised to x. Integral of e raised to power x is e to the power x, same thing, 0 to 2 pi. Put upper limit and lower limit 1 by pi. Put x equal to 2 pi minus e raised to power 0 is 1. Therefore, this is value of a0. Next MCQ, value of a0 is the Fourier series of fx. The formula is what? a0 equal to 1 by pi integral 0 to 2 pi. Okay, for the range 0 to 2 pi, x square dx. And what is integral of this? Integral of x square is x cubed by 3. Lower limit is 0, upper limit is 2 pi. Put x equal to 2 pi minus put x equal to 0. This 1 by 3 is as it is, I am writing here. Now this is 8 pi cube by 3 pi and 8 pi square by 3. Okay, 1 pi gets cancelled. So this is the value of a0. Similarly, the value of a0 is what here? 1 by pi integral 0 to 2 pi. Here the range is 0 to 2 pi. fx pi minus x by 2 whole square. Now 1 by pi integral of this, or you can add one more step, 2 square 1 by 4 I am writing, pi minus x power 2 dx is 1 by 4 pi. Integral of pi minus x whole square is what? Pi minus x power 3 by 3. And derivative of pi minus x, again we have to write in the multiplication like this. Okay, when you take integration of linear factor pi minus x power 2 is pi minus x raised to power 3 by 3. And derivative of this argument pi minus x, which is minus 1, I have to write 0 to 2 pi. Minus 1 by 4 pi as it is. Put x equal to pi. Pi minus 2 pi is minus pi. Minus pi cube means minus pi cube by 3. Directly write. Pi minus 2 pi is minus pi cube is minus pi cube by 3. And 3 you can take outside if you want. Minus lower limit. Pi minus 0 is pi cube by 3. Okay, now, next. Minus 1 by 4 pi. This 3 I am taking common. It will be 12 pi there. Minus pi cube minus 2 pi cube. Then minus plus 2 by 6. 12 is 6. Pi square by pi is pi square. Pi cube by pi is pi square. Pi square by 6 is what? Value of a0 in this case. Now similarly, the value of a0 here, how to find? The a0 is equal to 1 by pi 0 to 2 pi x sin x. This is fx dx. Here we have the product of two terms. Therefore, now 1 by pi, first function, integral of sin is minus cos minus derivative of x is 1, integration generalized by part I am using. Integration of minus cos is minus sin x for the limit 0 to 2 pi. But sin x for 0 to 2 pi is 0. See, sin x or sin nx, whatever. Sin x for 0 to 2 pi is 0. If you put x equal to 2 pi, sin 2 pi is 0. If you put x equal to 0, sin 0 is 0. So this will be, this has gone. A0 is equal to minus, I am taking outside, pi is there, x cos x, and lower limit 0, upper limit 2 pi. To put upper limit and lower limit, minus 1 by pi, put x equal to 2 pi, and cos 2 pi is 1, minus put x equal to 0, it will be 0, and this pi gets cancelled, it is a minus 2. Minus 2 is the value of a0. Write down the formula for a0, 1 by pi, integral 0 to 2 pi, and root of 1 minus cos x is the function, then 1 by pi, integral 0 to 2 pi, under root of 1 minus cos x can be written as 2 sin square x by 2. Okay, this is the trigonometric formula, no? under root of 2 I am taking outside, this under root of 2 I have taken, and 0 to 2 pi, under root of sine square is what? Only sine, is root 2 by pi, integral of sine is what? Minus cos x by 2 divided by 1 by 2. Yes, after that, this minus sign I am taking outside, root 2 by pi. This 2 will jump in the numerator, here 2 is there. Then cos x by 2, lower limit is 0, upper limit is 2 pi. Then next step, minus 2 root 2 by pi as it is. Here, put x equal to 2 pi. Cos 2 pi by 2 is cos pi. Cos pi is minus 1, minus lower limit. Cos 0 is 1. Now minus 2 into minus 2 is 4, 4 root 2 by pi. Okay, this is the value of A0. In online examination, the most probably the value of A0 will be asked. Okay. The value of A0 is the Fourier series expansion of this function. The function is split into two subintervals. Function, see, I am writing formula for A0, 0 to 2 pi, fx, integral of fx. In this problem, function is split into two subintervals. Therefore, I am going to break this 0 to 2 pi into 0 to pi and pi to 2 pi. Function is being integrated in two different subintervals here. Okay, just I have broken this into 2 because the function is defined in this way. Now, 1 by pi integral for 0 to pi, value of fx is what? Minus pi. This I am putting here. For pi to 2 pi, for next range, value of fx is x minus pi, and take integral of it. It's very simple. 1 by pi, integral of free constant, minus pi is minus pi into x, lower limit is 0, upper limit is pi. Integral of x is x square by 2, integral of free constant pi is pi into x, lower limit pi and upper limit 2 pi. Now, 1 by pi, put x equal to pi, upper limit minus pi square, put x equal to 0, I'll get 0. Here, put x equal to 2 pi. 2 pi whole square means what? 4 pi square. 4 pi square by 2 means 2 pi square. Put x equal to 2 pi. Pi into 2 pi is 2 pi square. Minus lower limit. Upper limit, now lower limit. Pi square by 2. Lower limit by putting x equal to pi. Pi into pi is pi square. Like this. Okay. Now, 1 by pi. This 2 pi square minus 2 pi square has gone, minus pi square is remaining, minus of pi square by 2 minus pi square. 1 by 2 minus 1 means minus 1 by 2, like this, minus pi square by 2. And 1 by pi minus pi square and minus 1 by 2 means minus 3 by 2 pi square. And pi square and pi gets cancelled, 3 pi by 2. 1 pi gets cancelled. Okay, this is the value of A0. Okay, you also can check the value because I may commit the mistake somewhere, So you have to check it once again. This is for you. Okay, similarly, you have to solve this one. This also you have to solve. This one. 2 problems for you. Now, we discuss the problems on 0 to 2 pi. And 0 to 2 pi is full range. Now, the Fourier series on minus pi. What is the difference between 0 to pi and see? Here is 0 to pi. In 0 to 2 pi, the interval is this 0 to 2 pi. On the right side of the 0, complete interval of course 0. But in minus pi to pi, what happens? If this is 0, this is pi, and at the same distance minus pi. So this is 0. Right? this interval is symmetric to 0. This interval is not symmetric to 0, but minus pi to pi is symmetric to 0. This minus L to L or minus pi to pi is symmetric to 0 on the left hand side of 0 and on the right hand side of 0. The same length of interval you will find. But here very quickly, the formula is same, only the limits are different. See, if the periodic function fx is defined on minus pi to pi and satisfy Dirichlet condition, okay, that is very important because function should satisfy all Dirichlet condition. Then Fourier series formula is same as that of 0 to 2 pi. Fourier series formula for 0 to 2 pi and minus pi to pi is same. Formula for A0 is this, formula for An is this, and formula for Bn is this. But here in Fourier series on minus pi to pi, we have facility to write directly An equal to 0 or Bn equal to 0 in case of even and odd function. So in short, I tell you what is even and odd function. Even function is what? Fx equal to f of minus x. Means if you replace x by minus x in the function remains unaltered, function remains same. So that is even function. Cos x is even function. X to the power 2, x to the power 0, x to the power 4, x to the power 6, x to the power 8, x to the power even positive number integer is even function. Odd function is what? See the difference. F of minus x equal to what? Minus times fx. If you replace x by minus x in the function, the negation of that function value you get. If your sine function is odd function, x to the power n is also odd function where n is odd and n is positive. It's one more important thing I tell you. See, odd function multiplied by odd function is even function. X is odd function, sin x is odd function. The product of these two odd function is even function. This function is even function, this function is odd function, even into odd function you will get the odd function, this complete function is odd, this is odd function, this is even function, odd into even is what? Odd function again, this complete function is odd function, here this is even function, this is even function, even multiplied by even function is even function. But there are many functions which are neither odd nor even. For example, e to the power minus x is neither even nor odd. E raised to x is also same, log x is also neither even nor odd. Now, if an even function fx is defined on these facts are very important. On these facts, the MCQ may be asked in examination. If an even function fx is defined on minus pi to pi range, minus pi to pi, not 0 to 2 pi, or minus L to L, then Bn is 0. For even function, Bn is 0, but it must be defined on this range. If a function is odd function, a0 and an is 0. But function must be defined on minus pi to pi or minus L to L. L is any arbitrary constant or L is a positive integer or any real number you can take. Very quickly, find value of a0. In examination, value of a0 will be asked. Find value of a0 for the following functions. Okay, in order to save time, in standard format of MCQ I have not written. See, this function is odd function x to the power 3. This function is odd function x to the power 1. This function is even function. This function is odd function. Even into odd is this complete function is odd function. See, even function into odd function. Even function into odd function is odd function. Here, this is odd function, this is even function, therefore this is again odd function. Even into odd is odd function. Is all those functions are odd function, function 1 to 5. But all odd functions are defined on minus pi to pi or minus L to L. Then in that case, a0 is 0. Value of an will be what? 0. As for all functions, value of a0 you can directly write 0, value of an you can directly write 0. But if you evaluate by using formula, you will get the same. Now, find the value of bn for the following functions. So you can find out the value of bn for the following function. See, this function is what? Even.
This is even function. X is odd, sine is odd, odd into odd is even. This is also even function. This is odd, product is even function. When function is even function, see, when function is even function, value of Bn is 0. Here in all the cases, value of Bn is 0. Now, value of A0 for the function minus pi to pi. A0, this mod function is even. See, mod functions are always even. See, A0 formula, this formula I am writing, A0 formula, value of mod fx is mod x, and this mod x is even function. Okay, mod x is even function. One property of definite integral I am writing, minus a to a, integral of fx can be written as 2 times 0 to a. We are integrating with respect to x, dx I have not written. So this is for even function. If the function is odd, then value of integral is 0. In 12th standard also many times we use this fact. Now 1 by pi 2 times 0 to pi, definite integral formula I am using, mod of x dx, and 2 by pi, this is 2 by pi, 0 to pi. See, for 0 to pi, mod x is x. Later on I will be telling you the mod function. For 0 to pi, for positive interval, mod x is x. Now integral of x is x square by 2. Lower limit 0 and upper limit pi. And put upper limit and lower limit, means put x equal to pi, means pi square by 2. Pi 2 gets cancelled and pi square by pi is pi. Directly writing. Value of a0 for this function is pi. Now you try to solve at your own. Okay, this is for you, this problem. Now value of a0 for this function. This function is odd function, sine function. Function is odd, defined on minus pi to pi or minus l to l. The value of a0 is directly 0. Value of a0 for the function fx equal to x square. This x square is even function. Mod x is even function, x square is even function. By using this procedure, you can find out the value of a0. Next, the value of a0 for this function. a0 is what? 1 by pi minus pi to pi fx. Now, directly writing, x integral is x square by 2. It is x cube by 3 minus pi to pi. Now 1 by pi is outside. Put x equal to pi, put x equal to minus pi. Then it will be 0, Minus of 1 by 3 I have written here x cube for minus pi to pi. Minus 1 by 3 pi. Put x equal to pi cube. Put x equal to minus pi cube like that. Then minus 1 by 3 pi cube, minus of minus pi cube means 2 pi cube. And here pi square, 1 pi gets cancelled, minus 2 by 3 pi square. This is the value of a0. Here, find out the value of a0 for this function. So what is the formula for Fourier series for 0 to 2L? This is coming under the change of interval problem. See, a0 by 2 plus summation n varies from 1 to infinity an cos of nx, and the space I am intentionally leaving the space, summation n varies from 1 to infinity bn sine of n space x like that. This is Fourier series formula for 0 to 2 pi. I want to write Fourier series formula for 0 to 2L, remember, okay? Where a0 is equal to 1 by pi 0 to 2L. This is formula for a0. Formula for an is 1 by pi fx cos of c and x, we are integrating with respect to x, and bn is equal to 1 by something here fx sine of n x, and we are integrating with respect. Here, this is the Fourier series formula for 0 to 2 pi. Fourier series formula for 0 to 2 pi. Here 1 by pi, 1 by pi, 1 by pi, 0 to 2 pi, 0 to 2 pi. Earlier we have done. But I want to write Fourier series formula for 0 to 2n. We have to make, see, this argument is multiplied by n pi by n. Is cos n pi x by n. Here pi by n. Is sin n pi x by n. N pi x by n is the argument of sin. Here 1 by n, 0 to 2n. 1 by n, 0 to 2n. 1 by n, 0 to 2n. Sin n pi x by n. Sin n pi x by n. These red entries, all red entries because of 0 to 2l. And the same formula will be for 0 minus n to l also. Okay, see the difference between the Fourier series formula for 0 to 2 pi and Fourier series formula for 0 to 2l. Now, very quickly, the value of a0 for the function fx equal to x. First of all, in Fourier series, we have to look at the range. This must be equated with 0 to 2l. 2 equal to 2l. Therefore, L equal to 2 by 2 means 1. The value of L is 1. The formula for A0 for 0 to 2L, 1 by L, 0 to 2L, fx, we are integrating with respect to x. Okay? Now, L is 1 in this case. 0 to 2, L is 1, fx is, we are integrating with respect to x. Now 1 by 1 is 1, integral of x is x square by 2, 2 I am writing outside. Now 1 by 2, put x equal to 2, 2 square is 4 minus 0 and 4 by 2 is 2. This is the value of A0. Let's find the value of A0 for this. Okay, this 0 to 4, you can equate with 0 to 2L and 4 equal to 2L. This L equal to 4 by 2 means 2. And what is the formula for A0? 1 by L. I am writing directly. 1 by L. 0 to 2L fx. Now, integration of this is what? X cubed by 3 is integral of x square. What is integral of x square? X cubed by 3. I am writing 3 outside directly. 1 by 6. 3 raised to power 4 raised to power 3. 4 raised to power 3 is what? 64. Put x equal to 0, upper limit minus lower limit. And this 64 by 3 you can write 32 by 3 also. This is the value of A0. Similarly, here the value of A0 you can find out. The value of A0 in the Fourier series expansion of this you can find out. See, 0 to 2. It must be equated with 0 to 2L. 2 equal to 2L means L equal to 2 by 2 is 1. Function 4 minus x square. See, directly write it. 1 by L. L is 1. 0 to 2L. 0 to 2L. L is 1. Fx 4 minus x square. And take integration directly. Very simple. 1 by 1 is 1. Integral of 4 is 4x. Integral of x square is x cubed by 3. Lower limit is 0. Upper limit is 2. Put x equal to 2 means 8. 4 into 8. Put x equal to 2 cube is 8 by 3 minus. Put x equal to 0, you will get 0 for lower limit. And 8 minus 8 by 3 is what? 24. 24 minus 8, 16. 16 by 3 is the value of A0. Okay, this is for you because here the total range is 0 to 2L. And this must be equated with 0 to 2. 2L equal to 2 and L equal to 1. Now, this is for you, but 1 by L 0 to 2L. Here 0 to 2, this is splitted into two sub-intervals, 0 to 1 and 1 to 2. Fx for 0 to 1 is pi x, and take integration directly. Integration of x is x square by 2, lower limit 0, upper limit 1. Integration of this is what? Integration of 2 is 2x, integration of x is x square by 2, 1 to 2. And put upper limit, lower limit. Okay, you will get value of A0. Okay, we don't have sufficient space here, so this part is only for you. Now, Fourier series for minus L to L. The formula is same. See, this is the formula. This is value of A0, this is value of AN, this is value of AN. For minus pi to pi. But in minus L to L, this argument must be multiplied by pi by L, that's all. Now, here find the value of Bn. Function is defined on symmetric to 0 interval. Minus L to L, minus pi to pi, symmetric to 0 interval. This is symmetric to 0 interval, this is symmetric to 0, this is symmetric to 0. This function is even function. This function is also even. This function is also even function. When even function is defined on symmetric to 0 interval, there Bn equal to 0 directly. For this function Bn is 0, for this function Bn is 0, for this function Bn is 0. Why? Because these are the even function defined on symmetric to 0 interval where Bn is 0. Okay, there Bn is 0. Now, similarly for odd, this is odd function, this is again odd function, this is even, this is odd, product of even and odd is odd, this complete function is odd again. All these three functions are odd, and all these functions are defined on symmetric to 0 interval. It must be defined on symmetric to 0 interval, minus L to L type. So when odd function is defined on minus L to L, then value of A0, you can directly write 0. Value of AN, you can directly write 0. Now, the value of A0 in the Fourier series expansion of this. What is the value of A0? The function is defined and x lies between minus 1 to 1. And A0 value we have to find. This function is what? Odd function. This function is what? Odd function. Odd function minus odd function is equal odd function. This is odd function. And when odd function is defined on this, the A0 is 0. Odd function is defined on symmetric to 0 interval. A0 is 0. Even AN is also 0. Now, very quickly, the value of AN, A0, in the Fourier series expansion of fx. This is even function. See, what is the formula for A0? A0 is, this function is even function. Even function is defined on symmetric to 0 interval. A0 need not be 0. AN need not be 0 on when function is even. 1 by L minus L to L fx, we are integrating with respect to this. Here L is 2, like this, fx is x square. Now 1 by 2, by property of definite integral, even function minus a to a 2 times. Okay, without using property of definite integral, you can solve x square. And integral of 2 gets cancelled. Integral of x square is x cubed by 3. Lower limit 0, upper limit is 2. Put x equal to 2, means 2 cube is 8. 0 cube is 8 by 3. Is the value of A0 for this function for this range. Okay. So similarly, you can find out the value of this also. See, A0 directly write now. L is 1 here. 1 by minus 1 to 1 minus L to L fx. You can use property of definite integral. If you don't use it is also okay. This is even function complete. Therefore, this can be written as 2 times 0 to 1. Take integration of 4 is 4x, integration of x square is x cubed by 3, lower limit is 0, upper limit is 1. Put x equal to 1 means 4 minus 1 by 3, and put x equal to 0, you will get 0, upper limit minus lower limit, 2 times, and what is it? 12 minus 1 is 11 by 3, is 22 by 3. 22 by 3 is the value of a0. Okay, this is again odd, this is again odd, and total function is even function. To try to find out value of a0, because this type of integral previously we have evaluated, integral of x sin x, use generalized bipart and get the answer. To almost all the varieties of the problem we have covered, in examination it is more likely that the value of a0 will be asked in the examination, and all formulae for 0 to 2 pi, minus pi to pi, 0 to 2l, and minus l to l, all formulae of a0, a and bn will be asked in the examination. In the next video lecture, we will discuss about half-range series and applications of Fourier series, that is harmonic analysis. We stop here. Thank you very much.